Okay, so we need to figure out where this light is going to emerge from the cube. So let's start with this first angle. We'll call that theta 1. Let's figure that one out first. So we're surrounded by air. Okay, so we have 1.0 sine 75 is equal to 1.56 sine theta 1. So if I solve that for theta 1, I get theta 1 is equal to 38.3 degrees. Alright, so now I need to figure out what's happening at this face. Now this is a right angle, so this is a right angle here. That'll save us some time. So this angle, I'll call this angle A here. Angle A is can be found by the fact that theta 1 plus 90 plus A, those all have to add up to 180 degrees, because this is a triangle, here to here and here. That's a triangle, and the interior angles of a triangle have to add up to 180. So 38.3 plus 90 plus A equals 180. That tells me that angle A is 51.7 degrees. Now, if I were to try to get the light out of the prism at this point, like this, with some angle B, if I were to try that, I would get 1.56 sine 51.7 is equal to 1.0 sine B. The problem is that if I multiply these two things together, I get a number that's greater than 1. This adds up to 1.22. And if I try to take the inverse sine, if I say B is equal to the inverse sine of 1.22, I get an error. So that tells me that that's not possible, that the angle of refraction is greater than 90. Therefore, this is going to do total internal reflection and come out here. Okay. Now, a shorter way to do this is to determine the critical angle, right? The critical angle here is the inverse sine of the exterior index divided by the interior, and that's 39.87 degrees. So if your angle of incidence is greater than that critical angle, then you get total internal reflection. So that's a shortcut. You can always just compare your angle to the critical angle, and since 51.7 is greater than the critical angle, there we are. Now, that means that this angle here is also 51.7, which means that this angle over here is 38.3 again. Right? We have the same math here. That is, these three angles here, here, and here have to add up to 180 degrees. And these two angles have to be the same, right? A has to be 51.7 because the law of reflection tells us that. Okay, so upon leaving the prism then, if we look over here, upon leaving the prism, we would say 1.56 sine 38.3 is equal to 1.0 sine theta f. And theta f works out to be 75 degrees, which is the same as our angle of incidence. Nothing wrong with that for a square. Okay, so there's our final angle.